Selecting elements of a set, lesson 15.3a. We're talking about combinations here, and if you haven't seen the previous 7 videos, you might become lost or confused, and they're linked in the description. You wouldn't go from level 1 to level 7 on a video game, would you? You'd lose a lot of information and tools. Permutations are concerned with order, while combinations are concerned with selection. In a combination, order isn't important. A combination of n objects taken r at a time is calculated by dividing the number of permutations by the number of arrangements containing the same elements and is shown as this, or you might see it in parentheses like this, but it's read as combination of n things chosen r at a time, or as n choose r. N choose r. Okay? How many combinations are there of the set JKLM, taken 3 at a time? And the combinations are these subsets. We have these 4 subsets. Now, if you look at the subset JKL, it's the same as the set KJL. They contain the same objects, and order isn't important. How many combinations of JKLM taken 2 at a time? The combinations are these 6 subsets. You wouldn't see a subset KJ because we already have a K and a J inside of a subset. Order isn't important, okay? For the problem of finding the number of permutations of n objects taken r at a time, NPR, we can think of this process in 2 steps. 1, we choose the r objects. 2, we arrange the r objects. And we can choose the r objects from the n objects in n choose r ways. Then we can arrange the r objects in r factorial ways. Now, I'm going to stop you. If you're really confused, you need to go back to 15.1a and just watch each video. In about a half an hour, all of your questions should be cleared up, okay? So by the fundamental counting principle, we can choose and then arrange in n choose r times r factorial ways. This means n choose r times r factorial is equal to npr. It's equal to the number of permutations of n objects taken r at a time. We know npr is equal to n factorial divided by n minus r factorial. We learned that in video 15.1d. This means we now have n choose r times r factorial is equal to n factorial divided by n minus r factorial, which suggests this, and that's our theorem that I'm going to show you, okay? The number of combinations of a set of n objects taken r at a time is n choose r equals n factorial divided by r factorial times n minus r factorial. Well, hopefully my colors here will help you, and we can simplify 5 choose 2. The 5 is our n, the 2 is our r. That gives us a 5 factorial divided by 2 factorial times 5 minus 2 factorial. 5 minus 2 factorial is a 3 factorial, isn't it? We learned how to do this in 15.2a and b. We can write 5 factorial with a factor of 3 factorial. And we can cancel out those common factorials. That means we have 5 times 4 over 2 times 1. That means we have 20 divided by 2, which is equal to a 10. We can simplify 7 choose 4. We have 7 factorial, and it's divided by 4 factorial, that's our r, times 7 minus 4 factorial. That 7 minus 4 factorial is a 3 factorial, isn't it? We can write the 7 factorial with a factor of 4 factorial. See how I didn't take the 3, I took the 4? That gives us 7 times 6 times 5 divided by 3 factorial, which is a 3, 2, 1, isn't it? Multiplied together. That's a 6. You're going to get to a point where you know 3 factorial is a 6 because it's an easy one. That means we have 210 divided by 6, which gives us a 35. All right? I've got a lot more for you here. We can simplify n choose 3. We've got n factorial. The 3 is our r. So we've got n factorial divided by 3 factorial times n minus 3 factorial. We can write this n factorial with a factor of n minus 3 factorial, like this, And we can then cancel out the common factorials, and we're left with n times n minus 1 times n minus 2 divided by 3 factorial. And that's as simple as we can get it. All right? 4 flavors of ice cream are chosen from a freezer containing 10 flavors. In how many ways can this be done? Well, there's no implied order here, so the number of ways 4 flavors can be chosen is 10 choose 4. 10 flavors, 4 being chosen. We have 10 factorial divided by 4 factorial times 10 minus 4 factorial. 10 minus 4 factorial is a 6 factorial. We can write the 10 factorial with a factor of 6 factorial. We can cancel out the common factorials, and we're left with 10 times 9 times 8 times 7 divided by 4 times 3 times 2 times 1, which is 5,040 divided by 24, which is 210. So there's 210 ways we can take that ice cream out of the freezer, okay? How many ways can a congressional committee be formed from a set of 5 senators and 7 representatives if a committee contains 3 senators and 4 representatives? Well, the 3 senators can be chosen in 5 choose 3 ways. 5 choose 3. And the 4 representatives can be chosen in 7 choose 4 ways. Using the fundamental counting principle, we've got 5 choose 3 times 7 choose 4. It's going to be 10 times 35, which is 350. How did I get the 10 times 35? I plugged them into our trusty little formula here. And for the 5 choose 3, we had 5 factorial divided by 3 factorial times 5 minus 3 factorial. That gave us a 2 factorial here, didn't it? We wrote the 5 factorial with a factor of 3 factorial. See that? That gave us a 20 divided by 2, which is a 10. For the 7 choose 4, we have 7 factorial divided by 4 factorial times 7 minus 4 factorial. That's a 3 factorial, isn't it? I wrote the 7 factorial with a factor of 4 factorial, canceled them out, and we had 7 times 6 times 5, which is 210, and 3 factorial is a 6. That was our 35. We multiplied them together and got the 350. All right? A pizza shop can make pizza in 256 ways. They use combinations of 1 sausage, 2 pepperoni, 3 mushroom, 4 onion, 5 green pepper, 6 olives, 7 spinach, and tomato is 8 toppings. A cheese pizza has no toppings, so that would be 0, wouldn't it? We can use combination notation to show the number of possible pizzas. There's 8 toppings. Each way of making a pizza is a combination or subset of these toppings. And there's 8 choose 0 subsets with no topping. That would just be a cheese pizza, wouldn't it? We'd have 8 choose 1 subsets with 1 topping, 8 choose 2 subsets with 2 toppings, and so on to 8 choose 8 subsets with 8 toppings. That would be a deluxe pizza, wouldn't it, with all the toppings? And we can write the total number of combinations or subsets in this combination notation. It's the sum of the quantity of 8 choose R as R goes from 0 to 8. And it equals 8 choose 0 plus 8 choose 1 plus 8 choose 2 plus so on plus 8 choose 8. Okay? Let's do a couple simplifying problems. Now, this one is n choose n minus 1, but I also wrote it with a number in it, a 5. In case you become confused, you can follow how I did what I did, okay? So if we have n choose n minus 1, we've got n factorial divided by n minus 1 factorial, because that's our r, isn't it? Times n minus 1, because we need n minus r. And the n is here, and the r is n minus 1, so we've got n minus 1. Does that make sense? N minus 1 is going to give us a 1. That means we have n minus 1 factorial times 1 factorial. That means we just have n minus 1 factorial down here. We can write this n factorial with a factor of n minus 1 factorial and cancel these out, and we're left with an n. So let's plug a 5 in here in case you're confused, you'll be able to follow along because I'm going to be using real numbers. If we have a 5 choose 5 minus 1, that's really like 5 choose 4, isn't it? That means we have 5 factorial. For our r, we have 5 minus 1 factorial. We need to do n minus r factorial, so we've got 5 minus 1 factorial. Well, if we had a 5 and did minus 5 minus 1, that means we have 5 minus 4, doesn't it? That's a 1. See how we got the 1? If we multiply 5 minus 1 factorial times 1 factorial, we're just going to have 5 minus 1 factorial. We can write the 5 factorial with a factor of 5 minus 1 factorial and cancel them out, and we're left with the 5. See how I got that? Does that make sense? I hope so. Let's try another one. We can simplify n plus 1 choose n. So here's our trusty formula right here that we're going to use to follow along. That means we have n plus 1 factorial divided by n factorial, because that's our r, isn't it? Times n plus 1 minus n. That's our n minus r factorial. See? We can expand and simplify this. And when we expand the n plus 1 factorial, we have n plus 1 n and n minus 1. These are all multiplied together. And when we expand the n factorial, we have n times n minus 1. We can cancel out this part, and we're left with n plus 1. Now, if you're really, really confused, we did this in video 15.1c. What if we put a 5 in place of the n? When we expand it, we'd have 5 plus 1, which is a 6, the 5, and 5 minus 1, which would be a 4, wouldn't it? That's how I got the n plus 1 times n minus 1 up here. See how I did that? It would be as if we had 6 times 5 times 4. And it's going to be divided by 5 times 5 minus 1, which means 5 times 4. We can cancel out the 4s and the 5s, and we're left with the 6. So see how I was left with the n plus 1? All right. Okay. Our very next lesson, we're going to talk about combinations and solving for n. When you see n choose n minus 1 or n plus 1 choose n, I'm going to show you step by step how to write these out and solve them. Okay? That'll be 15.3b. If this video was helpful in any way, please hit the like button so I know, and it lets YouTube know. And it lets other people know that this was a helpful video about combinations and n choose r. All right? I appreciate it. And I hope you have a great day. And I hope I'll see you for the next video. It should be very informative because there aren't too many lessons and explanations about n choose n minus 1, you know, when it's written like that. So I'll see you next time. Bye.